Hello, welcome to Happy Maths, a special live edition with Tony and Caroline. And today it's about the World Cup, football challenges, and finding the maths in football. So every Monday, 5 o'clock, we do our live session, or recording. There is a Happy Maths Hour every Monday, and we are taking advantage of the World Cup to look at football. Tony, are you ready?
Yes. Now, here's the question: where's the maths in football? And we thought that because this is near the end of term, um, teachers would be really happy to see some activities that they could give their children to do in class that relate to football. Everybody a lot of people, most people at the moment are interested in football. In this picture, what maths do you see in that, Caroline?
Well, I see lots of hexagons that tessellate.
That's the
I
net.
That's the net. I can see. I'm fixated on the direction all the footballers are looking. So you can, even if the ball were missing from the picture, I think you could play a game where you could guess where the football is. And what else I see? I think about how many people there are in the stadium. I think about how far, I suppose people that know how big a football pitch is would just know, but you can still estimate how far it is between the goalposts, between the goals
I'm
from one
also
pitch to the
seeing
other.
I'm also seeing that this is an action photograph, and the footballer has just kicked the ball. It's coming towards the goal, and the goalie is now diving to save the goal. But the maths that's going on in the brains of those footballers is amazing. They're not consciously thinking about speed and distance and angle, but their brains are doing the maths and coming up with it. I thought we might start looking at this problem about this particular stadium that was built for the 2010 World Cup in South Africa. At that time, Spain beat the Netherlands. Who's going to win this time, do you think, Caroline?
Almost certainly not England, let's put it that way.
Oh dear. You're one of
Yeah,
those people who say that France is going to beat England and that'll be the end of our story.
sorry. What happens is England ends up with a tie, and then England, when it comes to breaking the winner with the tie, England just doesn't do it. So maybe this year will be the exception. I mean, it's
Oh, well,
been how many years? It's
they've got
been
through to the quarterfinals.
done
Well,
it before,
anyway,
been there, done
here's a
that.
diagram for you. Can you make sense of it? What it is a football pitch. Caroline, did you bring your little demo? Here we go. So, can you turn it round, Caroline, so that yes, that's right. Right. No, no, another 90 degrees. Now, if you make the triangle, fold it along the edge PC so that the top of the triangle, not flat, Caroline. It's meant to show what this diagram
Oh
shows.
right, so
A
I
is
need it. I need
supposed
it that
to
way
be
then.
the vertex is supposed to be directly above. There you go. The vertex is supposed to be directly above the center of the pitch.
I was doing it the other way around because the image is inverted. So yeah. I'm there.
Okay,
I'm there.
so
I'm there.
as I
So
see
this
it,
is the
this flap, this triangular flap, was flat, and Caroline has um, folded it up to show the vertex vertically above the middle of the pitch, and to show that you've got a right angle triangle PAC and another right angle triangle CAM. And with some calculations, there's a picture of the what Caroline's using, the model she's using, and the Yes, and by scale drawing, you can answer all those questions. Or you can use trigonometry if you want
That's
to
what I
get,
really like about this.
yes,
Yeah,
but you've got
because a
to,
lot of people maybe have forgotten about trigonometry, and so what I really like about this is that you really can do this just by measuring, just by scale drawing, and you can find the solutions. And so
so it's a
just draw
suitable
it to scale.
it's a suitable exercise for younger learners or older. Now, I found these pictures of the stadiums that Qatar has built. Aren't they beautiful? And why are they
They are
beautiful?
stunning.
Yes, and it's a view that these are views that not many people get because you've got to be up in the air, haven't you, to see them from the angles that you see them now.
You've got the
They
minimal surfaces on the Al Bayt Stadium. You've kind of got the minimal surfaces on the roof,
mm,
kind of the bubble effect with the curvy.
mm, mm.
And you've
And
got
you've got
triangles and trapezia on the Education City Stadium.
and they are all different. They're all, I mean, imagine the maths that went into the work of designing them to get all the proportions right and the symmetries and the shapes. They're absolutely beautiful. I
And then the
found out,
project planning, not just designing them, but then actually working out what is required to build them, all the project planning, or what equipment, how much equipment, how many people, and they're getting the times right, getting it ready on time. Absolutely. Oh, and I hadn't noticed the shapes on the base of the Al Tumama Stadium. Got the circular, cylindrical stadium, and then on the outside you've got all those quadrilaterals, or not quite sure. They look like they're intersecting quadrilaterals from here on the
mm,
outside.
mm. Now this is interesting. The 974 Stadium, I wondered why that was the name of it. And that's because it's the telephone dialing code for Qatar.
Oh,
But it's made of 974 shipping containers. I love all the colors in it. And it's going to be dismantled after the World Cup and the components will be reused. Now, isn't that clever? I
that's
think that's
fascinating. What an amazing idea somebody had somewhere along the lines, like, oh, why don't we build it out of shipping containers and then reuse it? Okay, let's do it.
and this is also interesting. This Al Tumana Stadium, the shape is inspired by this cap, which is called a kafia, which is part of the Arab headdress. So
Mm.
they put the cloth on their heads and they put the cap on to hold it in place, and then there's a band that they tie round. I think I got it right. But the word kafir also refers to a form of Persian poetry, and it's very significant in the Arab culture. So that's why that stadium was designed to be circular and to be that in that pattern. Isn't that
And,
interesting?
and I just thought of the rectangles or whatever the shapes are on the base and around it. That's reminiscent of the Arabic um, geometry in the Alhambra, and well, basically all the buildings,
Mm,
the
mm, mm,
geometric shapes that decorate the buildings. They've
mm.
done that on the grounds of this stadium.
Yes, I think those are stunning pictures. So what's going to happen after the World Cup is that the stadiums will be modified to provide facilities for other sports as well as football. And to make way for that, some of the seats will be moved out. So, for example, the Education City Stadium will become a sports complex. It's called Education City because it's in the area in Doha where there are 3 universities. So the new sports complex will have facilities to serve the students in the area. And the Lusail Stadium will become a community centre. And around 174,000 seats will be disassembled and sent all over the world to developing nations to help them to develop their sports infrastructure. So
Okay.
that 22 new stadiums will be created in emerging economies. And this configuration will leave Qatar with stadiums with between 22 and 25,000 seats, which is suitable for all domestic needs. I think when you see those facts and you look at those beautiful stadiums which people are watching the games in, really Qatar deserves more praise and more, great thanks really from the rest of the world. And it seems all, looking at the news, they've received nothing but criticism, which is such a shame.
Suppose, yes, it is the bad has outweighed the good in this instance, but there's still lots of people watching. So,
well, it's getting a sense of proportion, isn't it? But the fact that this is going to develop to help developing countries is good, it seems to me. So, okay, so here's another problem. Now this was the original lineup of 32 teams that started, and now of course we're down to the 16. In fact, some of those 16 teams have already been knocked out. Okay, so there's how many teams qualified for the last 16? Well, these are not how many. These are the teams. So England has just played Senegal, and then we'll go on to play France. And I don't remember who's playing who in the next few weeks, but in the next week. But by Friday, these 16 will be reduced to 8. So now in the group rounds, each team plays all the other teams in their group, and they play them once. So 2 teams from each group qualify. So how many games are there in the knockout rounds, Caroline? Can you work that out?
Right. So each team has to play each other. So that's 3, and then that team plays 2. So that one, that's 6, I think. So that's 6 times 1, 2, 3, 4, 5, 6, 7, 8. 6, 8 are 48.
48. Yes. Well, what we have is that each team plays all the other teams, and so in that group, so the 4 teams play the other 3, which makes 12. And you get 6 because when you say 4 times 3, it counts the same game for both teams. And so that's why you get 6. And in the knockouts, well, we'll come to that in a minute, and how many games there are in the tournament. And this diagram might help, it might not. Is it a good chart? Doing maths, we use charts to illustrate, to convey information in a way that it's perhaps easier than just reading text. The question is this a good? Is it a good chart? Is it misleading? Well, that's really. I looked at it and I thought, wow, this is brilliant. And then I tried to work out certain things from it. And then I got completely, oh my goodness, it doesn't show me clearly what's going to be happening. I was talking, Caroline, about whether this is a good chart or not. So everything got started on the 30th, on the 20th of November. That was from the 20th of November, but and the quarterfinals will be from the 9th of December. That's Friday. At the moment, we're in the round of 16, and this week we're in the round of 16. But it appears here um, as if the two teams that come from the group where England is at the top somehow seem to play each other. Well, we know they didn't. We know that England played Senegal. So this fork, these 8 forks, I think, are quite confusing.
Yeah, it implies what we're looking at here implies that the quarterfinals, that there's 2 teams from each of the groups make it into the quarterfinals, and then the semi-finals, it's 2 of those. So it's only between those 4 possibilities are only between those 4, and it's not that at all.
Well, that is what happens, isn't it? Because the 2 teams who is that right? The 2 teams, they don't play each other, but they play other teams.
Yeah, but they don't play each other, and this does imply that they play each other.
It sort of suggests that, yes. Yes. Anyway, I thought that was somebody's good attempt to show how the process works.
It's certainly structured, but I suppose they shouldn't be. Maybe they should be at the top. Maybe the eight groups should be above, and then have the chart below, so that it doesn't.
But then there would be I think that would be better, and then there might be a crossover, and it go down.
Exactly. You could then have arrows pointing down.
Mm-hmm.
So we've got a comment, Tony, or question: is England that's got to be an opinion? Is England going to take it this time? And what is the percentage? Well, I'm afraid I'm going to say West Ham doesn't have enough players playing, so we're not going to win.
Oh, Caroline. Oh dear. No. I find myself very conflicted here. I almost wanted to cheer for Senegal last night when they were playing, because rather than England, because Senegal were the underdog, and I like to support the underdog.
I always cheer the underdog. I was rooting for South Africa when it was there. I was rooting for Iceland that year. Oh my goodness, they put up such a brave show. I'm always cheering for the underdog.
I wanted Senegal to get at least 1 goal.
that must have been really disappointing for it to be 0.
So then what's happening now is that 2 teams from each group are involved. So there are 16 teams. The 16 teams are playing this round of 16, and then 8 of them will go through to the quarterfinals. There'll be 4 games in the quarterfinals, and 4 teams will go through to the semi-finals, and then 2 teams to the finals, and then there'll be another match after that or before the final. I'm not sure when it happens, that will decide third place. So there are so this is how many you get. There are 16 teams, and 15 must be knocked out. This is 2 methods of doing this. 15 must be knocked out to determine the winner. So that means 15 games with 1 team knocked out each time, and there's also a game to determine third place. That's 15 plus 1 is 16 games. Now, that's the other way. Which way seems better to you, Caroline, of these 2 methods of working out how many games?
I like I like method 2 purely because I can follow it. I can follow it step by step. I like that. It works with the way my brain works.
Like,
But
quite
I also like the logic that there are 16 teams and 50 must be knocked out, and then you've got the extra game. But I would have to really think about that carefully and make sure. I'd have to go back and really basically do method 2 so that I was sure that I got method 1 right. So maybe a combination of them both. One checks the other.
So you've got 48 games in the groups rounds and then 16 making 64 altogether. How about this, Caroline? Have you got your ball handy?
I do. Get ready to see the buckyball.
Now, of course, this isn't the design of balls that are used in the World Cup, but it's the classic common football. And Caroline made it from this net that you see on the screen. Isn't it beautiful?
It's lovely. I feel like putting something inside because it's quite delicate. You cannot I've had to pull out a couple of the flaps. It's all taped together, but I feel like putting something inside so I can actually keep it and it will last. Because although as long as nobody touches it, it's all right. But it's definitely not something you can have rough people playing with because they'll squish it. But you can make it and then just put it on top of something, which I will be doing. And I really like it, actually. I treasure that.
It's made with quite thin card, isn't it?
Well, I just use normal paper, so if I'd made it with card, it would be a lot more substantial.
And this is what we call an inflated. The football itself is an inflated, truncated icosahedron. So
Now that's a mouthful. Can you say that 3 times in a hurry, Tony?
Inflated, truncated icosahedron. Inflated.
You can too.
And now it's also called a buckyball because it's named after Buckminster Fullerene, and he was a scientist and a builder who
Buckminster Fuller, Tony. It's Buckminster Fuller. It's a
Fuller.
Buckminster Fullerene.
Fullerene was the carbon atom that he identified, wasn't it?
Yes.
Yeah. Okay, and anyway,
and then it's the carbon 60 molecule, which and the geometric shape. Also, they named the Buckminster Fullerene as in maths. And then the football is I like it, inflated truncated icosahedron. But why on earth is it a truncated icosahedron? Surely that's not the name of that. It's the football, right? Or a carbon 60 molecule.
Well,
why do we use icosahedron?
Before it was inflated, you see the 2 pictures of the black and white pictures. The actual polyhedron on the left, and then how it's inflated air in it makes
I can see the inflated part. What I'm intrigued about why it's a truncated icosahedron. It doesn't look like an icosahedron.
Well, let's first of all, let's come back to that question. Let's count the faces. And if you count the faces, you have got 12 pentagons, the red one.
Oh, yeah, no, now I can use the other method that you used. I've got two hexagons in each column. So 2, 4, 6, 8, 10, 12, 14, 16, 18, 20. So that's 2 times 10. And then there's 12 pentagons. That's quite easy to count on. I tell you what, Tony, counting them nice and flat like that is so easy. You attempt to count them when you're actually going round and round a buckyball. It's a very, very different matter.
Now, how many edges are there? Well, there are 20 hexagons, each with 6 edges. That would make 100 and 6 20s, 120 edges.
Right. Yeah. So that's okay. Yeah, I got that. 6 times 20,
there are 5 of them. That would make 60 edges, and adding those up, that would be 180. But then each edge or 2 flat faces is joined to the edge of another flat face. So we've got to divide by 2 to get 90.
Yeah. Every edge has 2 faces. Yeah, I can see that.
So similarly, when we count vertices, there's 6 vertices to each hexagon and 5 to each pentagon. So there's 120, but each one is counted 3 times because there's 3 faces meet at each vertex.
So let's just check that. I've got a vertex there. I've got 1, 2, 3. So each vertex has 1 pentagon and 2 hexagons. That makes 3, of course. And they're all exactly the same. Every vertex has 1 pentagon and 2 hexagons. So yeah, there's 3. Yep, I concur.
Right. And if we add the number of faces and the number of vertices, and then subtract the number of edges, we will get 32 plus 60 is 92 minus 90, and the answer is 2. And if we count faces, edges, and vertices for any polyhedra, we'll do that calculation at the bottom of the screen here, we'll always get 2. That's Euler's formula, or Euler's constant. So let's look at the icosahedron, and let's look to see what happens. Now, the icosahedron has got 20 faces. That's the icos word means 20. Yep. It's also got 30 edges and 12 vertices.
So the icosahedron is the one on the left that's got lots and lots of triangles. It's got like 3, 4, 5, 6, 7, 8, 9. It's got 9 triangles on every face. That's the icosahedron. It's made up of 20 triangles, right? On the left.
I'm going to see why I have put 9 triangles on every face here, because we're now going to imagine ourselves with a knife cutting off pieces of that icosahedron and producing the shape on the right.
Okay, so I can see on every vertex, you can actually see the shape of a pentagon just under it. So you're actually cutting off a pentagonal pyramid off of every vertex.
Yes, there you are.
Right.
Red lines show the cuts. And when you do that cut and pick off these 12 pentagons, you have left a flat area. Well, if you're working with something solid, you've got to be solid, then you're left with the flat pentagonal face, which is in red on the picture on the right. So that truncated means cut off, and you see that each pentagonal face is surrounded by 5 hexagonal faces, and in the original icosahedron, there's the 3 of the triangles you see at the vertices. They are they're the cut lines that you cut when you cut off the pentagon.
Right.
Flat the other 6 triangles making the hexagon. You see there were 9 on the face of the icosahedron. So the 3 of them belong in the pentagonal pyramid that's cut off, and 6 of them are on the flat face, which becomes the hexagonal face of the buckyball.
Right. Yeah. I can see that. So yeah, you started with 9 and you've literally cut 3 off every face, and that leaves 6, and that's irregular. They're all the same. They're all equilateral. So that leaves you with a hexagon on every face, apart from the face that's been cut off. Cool.
Cool, yes. Now here, we've got some results, and the puzzle is which chart. There are 6 charts, okay. Now, number 1 mentions Beta Rovers, and number 3 mentions Alpha United, but numbers 2, 4, 5, and 6 don't mention which team. So the puzzle is, you know, that 3 of these charts or pieces of information refer to Alpha United, and 3 refer to Beta Rovers, but which is which?
Okay.
So you've got to pick out pairs and put them together. And then if we're going to find out which is which, it seems you've got to work out, well, the learners, if you do this, if you're a teacher and you're going to offer them this in a lesson this week, then they need to work out mean, median, and mode. So it's a good incentive to work out the averages, the three averages, mean, median, and mode.
Right. So by working out the mean, median, and mode, you can identify which of those charts refers to Beta Rovers and which of the charts refers to Alpha United.
Indeed. But
okay, it's a nice little puzzle then. It's like a mix and match, but you've got to work out the averages in order to complete it.
Yes. So you should be able to see which is the mode. What's the mode in the pie chart?
The mode in the pie chart is one goal.
And what's the mode in the pictogram?
The pictogram, let me see, the one with most, so there's one with 2.5 footballs, and that's 3 goals. So the mode in the pictogram is 3 goals.
Yes. And so the pie chart and the pictogram must refer to different sets of results.
Yeah, that's right. Yes. Oh my, yeah, because the pie chart, the biggest section is the 1 goal section, whereas in the pictogram, the biggest section is the 3 goals, the 2.5. The how many goals? That must be, yeah, sorry, the 3 goals section, which is 2.5 match.
So which of the frequency, look at the frequency chart now, and the tally chart, numbers 5 and 6, which shows a mode of 1 goal and which shows a mode of 3 goals?
Right. So the frequency chart, the mode being the one that occurs most often is 1, because that scores 6 matches with 1 goal. And that would then match the pie chart because that's the biggest, and yeah, it tells you the 1 goal is the biggest section, and then you look at the tally chart, and that shows you that the most amount of goals is 5, and that matches the pictogram. Okay, so we at least we know which 2 charts match each other.
If your class were trying to do what Caroline and I are talking about, they'd already have revised and recalled and reminded themselves, each other, of what the mode is, and you're partway there. So we've decided that the tally chart and the pictogram both represent the same data, and the children can work out the mean. The mode we've decided, we saw that immediately, was 3. And to get the median, you have to list the occurrences. 0 happens 3 times, 1 happens 3 times, 2 goals happens twice. You've got to list them in order and find the one in the middle. That's the median. So so we won't calculate the mean.
Well, you can see that. You can see it in the kind of the old-fashioned way, the way you learn in primary school, isn't it? The median goals, you've actually listed them all out.
Yes, but the mean, you have to work out the total number of goals, which is 30, and divide it by 15, which is the total number of matches. So the mean is 2 goals per match. So does that relate to Alpha United or Beta Rovers?
Let's see. The mode number of goals scored by Alpha United is 1 more than the mean number of goals they scored. So the mode, it certainly is true for the mean. Yes, this is true for Alpha United. What about for Beta Rovers? The mode of the number of goals scored is 1 less than the mean. So that is not.
So it must be Alpha United.
Must be Alpha United, yeah.
There's a summary of the results for Alpha United. And then for the other team, this must be Beta Rovers, you do the same thing. Here, again, when you work it out, you've got 30 goals scored altogether in 15 matches. So the mean is the same. It's two goals per match. But now the mode is 1, which is 1 less than the mean. And it's Beta Rovers. And there's the summary. So you're really doing some, if your class does this exercise, this puzzle, then they will have revised a lot about mean, median, and mode, and it will seem to them to be fun, probably. Codes. So what does this 1,994 plus 6,533, we add those up, we see we get 8,527. So
Okay.
what's the hidden message?
All right. The hidden message. Well, it says there's a key at the bottom. There's a key or code book at the bottom.
Yes.
So A is 5, B is 6, E is 7, and so on. So if I just substitute 1 for F, 9 is O, 4 is T, foot. Oh, I've got foot. And this has been about football. What could the next one be? B is, I'm going to guess. I'm going to say it's football. What's the last letter there? What's the last word?
8 is G. 5
A.
is
I'm going to guess it's game.
And
yes, football game.
That's exactly what it is. Okay. And this is a cryptogram. It's the letters in foot plus ball equals game can be replaced by those numbers, and the sum, the arithmetic, is correct. But there's a lot of interest in codes and secret codes, and of course this is a very easy code, but yes, that's a little exercise your class could do. Now, can we get other solutions to this puzzle? Can we find other substitutions which will, of the numbers 0, 1, 2, 3, 4 up to 9, which will make a sum here that's correct?
Can we have the first one so I can write that down to see if I come up with something different? Oh, that's different. Oh, that's okay.
So here are 3 examples, okay? But what we've done here is to make it easy for you by giving you some of the numbers. So the bottom one there isn't going to turn out to be 1994. I mean, if we go back to the one we just had a minute ago.
Yeah, that's what I want to do. Write that down so that I'm not repeating. So I know I've got something new. 6533 and 8527. But I've now got that all written down, so I know that T can't be 4 because that would be repeating. That would be something new.
I might have got that wrong. Actually, it is. It's a repeat of the one we've just had. Okay.
Oh, okay.
Yes, the T is 4, the L is 3, and the E is 7.
Oh, that's it. There's actually something intriguing there because it's a little bit like Sudoku but there's 10 digits. There's 0. You can choose from 10 digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9.
That's
and
the
then
only way, Caroline. That's the only
you can cross them out.
But
Sorry.
Well, yes, but that's the only way it's like Sudoku, because here you've got some arithmetic involved.
Oh,
with
sure.
Sudoku, you're just making lines and of rows and columns of numbers and putting them in a 3x3 box.
But what I mean is you can eliminate all the numbers that they absolutely can't be. So it can't be 1, it can't be 9, it can't be 6, it can't be 5, it can't be 3. 8, 5. Oh, 5 is repeated. Oh, we don't know what letter. So actually,
no, that's because there are 2 A's and 2 L's.
Oh, okay. No, so the pattern's the same. The pattern is the same. So 5 and 2. So we have to choose from 0, 4, and 7. So T, we can test T being 0, 4, and 7, but it can't be 0 because if it was 0, then L and E would be the same number. So it can't be 0. So that leaves 4 and 7. So could it be 1997 plus? No, because L has to be 3.
Exactly. You know L's
L
3.
has to be 3. Okay, so since L has to be 3, then there is only one solution to that one.
So what you find is, once you've got one solution, you can often tweak it a little, just make a small change in one of the digits or one or two of the digits and find other solutions. And actually, there are 224 solutions here. So you've got to, it's going to go on challenging you to find more and more, or challenging your class or your group or your family to find more solutions if you're interested. There's another one on the right there, 2,997 plus 3,411.
Oh, what inside the picture? I see it. Yes, it's
Inside
underneath
the
it. Yeah,
picture. That gives you 6,408.
right.
What I mean by two solutions the same, the 2004 solution can actually have 3977 for ball or 3677 for ball. So once you find one solution, it's worth playing around to see if you can tweak it a little and find other solutions.
Right. Yeah. And you can do the same as you can basically the numbers that can't be are the 2, the 0, and the 4.
Yes, exactly. And then the 1007 solution, and also the letters you're trying to replace. Well, you know L is 8. That's fine
Yes.
because
Yeah,
of
we know
ball.
L. Yeah.
We know the other numbers can't be 1, 7, 2, and 8, and
Yeah.
0 because those numbers are already used.
Right.
And so, but when you find any one of the solutions listed in that on the right-hand side of there, the 1007 plus something, you see that there are 4 solutions that are all very much the same. So if you look, you can quickly get more solutions this way, but as soon as you find one.
Yeah,
But
and L. Oh no, we know L is 8. So actually, we know what the M and the E are going to be 9 and 5 every time. Because 9, where'd I get that from? 1 and 5. My brain's gone for a loop now. I'm making the last one 15, and L is 8. That's why it's got to be 9 and 5 every time. The answer is always going to be the last 2 digits are going to be 9 and 5. So it's only actually 2 letters that we need to work out after that.
yeah, and there's only one solution with this 1994.
Yes, I managed to conclude that because L is 3.
Yeah. Now, actually, it turns out that the letter O can only take the values 0 or 9, and the reasons are given here, but I don't think we want to dwell on it now. But if you think about it, you can probably work out why O can't be anything else other than 0 or 9. And it's all to do with carrying numbers over when you add up, whether you carry over from the units to the tens or from the tens to the hundreds column. So either one's carried over from the tens column to the hundreds column, or it isn't. And there are 2 possibilities.
Right.
And in one case, the letters O stands for 9, and the other case it stands for 0. Anyway, all the solutions there and a pseudocode for writing a program to solve this puzzle are all on the Aiming High website. And if you do a bit more reasoning, you can find all the TL pairs, and then you can use those to find all the solutions. So you can, if you can split this work between 30 children in a class, nobody's having to do very much, and you'll soon find your 20, all your solutions. So that's another one. And so there's lots of maths in football. There's another problem that that I might show you. I didn't make a slide for this, so I'm going to it's going to get rid of this now and find the slide if I can. With it on. I'm just going to be, you talk, Caroline, and I will find it while we're talking.
Okay, so I'm going to say that activity that Tony suggested of working out why the O's can only be 0 or 9 is, we haven't covered it, but actually it's a very engaging activity. And as Tony said, it's very helpful for working out and understanding place value. But it's a very satisfying activity, because you can start looking at it going, yeah, well, I don't know, or it does it matter? I don't know. Lots of different things you could think. But when you actually get into doing it and you realize that you've actually worked out that 0 and 9 are the only possibilities, it's incredibly satisfying activity. So I recommend that you actually have a go and prove to yourself, satisfy yourself, that O can only be 0 or 9.
Well, the thing is, I like it because it's a logic puzzle. I mean, you've got to think logically, reason logically. I didn't want us to go too deep into this, because this is a discussion about maths. We're not actually, it's not a lesson. We're not teaching, we're not aiming to teach anybody any maths. But as I pointed out, you'll find it on the Aiming High website. It's called Football Challenge, and just search for that and the key and the search, and you'll find all the solutions there. But I like it because it's a challenge that you can share with other people, and everybody can contribute some of the solutions. And then, between you can provide. I like the idea of putting a poster on the wall in the classroom, and as soon as somebody finds a solution nobody else has found, then you put it on the poster. And also, once you've got solutions, you can begin to organize them in a systematic way. So either you can think of your system that's going to provide pathways to finding the solutions, or your learners or your participants can do some trial and error, and then they can start to, this is a solution, this is a solution, this is a solution. How can we arrange them in a pattern to show how there's sort of different sets of solutions, like the sets I showed on the slide. So, Caroline, what do you think about this problem? No answers given. And it says, put your solutions in the comments, which you can do now, or this is going to be on the AIMSEC Facebook page tomorrow, and you can put your solutions there. This is a nice...
Teammate gets 11 points. No answers given. Okay, yeah, you keep talking. I'll be working it out. Let's have a look.
Teammate gets 11 points from playing 7 games. What are the possible numbers of games it could have lost? Now we've got to work this out, knowing that teams get 3 points for a win, 1 for a draw, and no points if they lose.
Oh, so these aren't goals. Sorry, that's a distinction there. These aren't goals, these are points. Sorry, so they get 3 points if they win,
2 points for a draw, and no points if they lose.
Oh, and it says it underneath the picture. Of course it does. So no points if they lose, and they're getting 11 points. So 6, to and the question is, what are the possible number of games it could have lost? Right, I'd have to sit down and do this over a cup of tea, Tony. I certainly wouldn't be able to work that out just off the top of my head right now, live.
Well, let's do it by trial and error, Caroline.
Oh, I can do that. Yes. Well, I've started to do that.
Yeah.
So
that's the best idea.
So I'm glad, because that's what I was doing. So team A gets 11 points, 7 games. So let's say they can't have won all 11, but if they drew to get 11 points, if they won 3 and drew 1, they would get 11 points.
Yes, but how many games? So how many games would they lose then?
So that would leave them with 3 games lost in that situation. Win 3, draw 1, lose. That would be lose 3. If they won 2,
I think that's the solution, Caroline. Win 3 and draw 1. No, that's only 10 points. That's not 11 points.
Really? So that's 9. Win 3 is 9 points. Draw 1 is 2 points. I make that 11 points.
No, they get 1 point for a draw.
I wrote 2 points for a draw in my notes. So
that would be okay.
So it would be win 3, draw 2. So that would be lose 2.
And that's the solution. You've got one right away.
I've got 1, yeah.
So what happens if they win 4?
If they win 4, we go over the top. There's too many points. We can't do that.
So that's no good.
We can't do 4. What about 2? If they win 2, if they won 2, that would be 6 points. They'd have to draw 5 and lose none.
But that would only be 7 games.
Oh,
that would be right.
That's it. 7 games. Yes.
So they win 2, that's 6 points. Draw 5, that's 5 points. 6 and 5 is 11. And then they will not lose no games.
And if
they've got 2 solutions. Okay, so
what if they win 1? Then there's not enough games for that to work. If they win 1, that's 3, and even if they drew on the remainder, that's only 6. That's 9. So actually, the only solution is that they won 3, drew 2, and lost 2.
Okay, that's right. So this is such a nice problem, because it's something that needs you to think logically, but you actually can easily do it by trial and error. So what about the second?
I did it live under all the pressure. So yes, it's
what about the second one?
It gave me a lot of reassurance that I was okay if I did it by trial and error. So that's nice. And then once I started working on it, then the answer just came. So that was nice. Thank you, Tony. Sorry.
What about try the second one?
Okay, so Team B loses its first game, but it gets 14 points from playing 8 games in all. So that's 14 points from 7 games. Or is it 14 points from... Is there a total of 9 games?
8 games here.
Total.
For me, it says 8 games.
Yes, but it loses its first game.
All right, so it's going to get... So we've got 7 more games, in which
case... so it's okay. So I'm just going to focus on that. We've got 7 games and 14 points. So let's go with what we did before. If they won, they could win 4. Could they win 5? 5 3s are 15. Let's go with that. So win 5, that's 15.
That's too many points. So...
Oh my goodness, I was looking at 17. So win 4. 4 times 3 is 12, right? So, and then if they drew 2, that's 6, and then they could lose 1. That would be... and then they'd already lost 1, so they lose a total of 2, and that's an earlier loss of 1. So that would work.
4 wins, that's 12 points. 2 draws, Right.
That's 2 points.
And 2 losses,
2 losses.
because there's
Yeah,
got
2 losses, including the first one that we already know about. Yeah.
yeah. So that's one solution. Now, are there any other solutions?
Okay, so if they won 3, that would be 9 points, and they got 14 points, so they've got to get another 5 points. So they'd have to draw 5. So that's 5, 8. Not enough. No, they'd need to do that. They'd have to play, because they lost one already. They'd have to play 8,
So
9 matches, and
that's not. So there's only one solution.
yeah, and that's that. What is the question? How many games did it win? And that the answer is 4.
Yes. Yes. So that was a nice question, I thought, because it's
I agree.
really
I definitely
easy,
agree.
but
Yeah.
really easy, but you've got to think.
Yeah. And the maths is highly, the maths isn't scary at all. But you've also got to get it right. There's me going, oh, yes, if I have 5 games, that's going to give me, so I've got over the top already and didn't realize it and all of that. So it's useful to have the double checking going on.
But I think we've come to the end of our hour, Caroline.
I've enjoyed that thoroughly. Thank you, Tony. I like being made to think. And it wasn't like really big brain thinking. It was just nice little puzzles and with very satisfying solutions. Thank you.
Okay, so goodbye, everybody. Goodbye.
We'll see you next week. Happy Maths Hour every Monday at 5 o'clock UK time. And thank you for joining us. Thank you very much, Tony.